Being a mother of a child with AHC, which is a serious neurological disorder, I can see many of these disorders share the same symptoms. It is critical to find solutions for the hundreds of millions of people that are affected by these disorders.
AHC is a complex and rare disorder for which the biggest experts are parents and families of those who have a child with AHC. It's a very exciting time. We've learnt more in the past 3 years than we'd learnt in the previous 20, but there's still an awful lot more to learn.
I think the possibility of a cure or better treatments are a real possibility. It's impossible to know how long that will take. For those of us interested in research for the improvement of the lives of children with these rare diseases, such as AHC, one strong motivator of all of us is to see one day when a treatment can be realized.
If we find a solution for AHC, it may well help other disorders, not only from looking at the gene, but also looking at the way we've got there.
There must be data out there of other diseases with epilepsy, hemiplegia, that we could make access or get access to, and then combine with the data that we have from AHC. And hopefully by combining information of different patient groups, we are so lucky that a picture emerges.
By studying a rare disease, you can actually begin to understand more common diseases such as epilepsy, dystonia, and Parkinsonism, which all have features that we see in the disease of ATP1A3.
Any discoveries and any increased understanding of the depth of how ATP1A3 dysfunction affects the brain can only benefit other patients that number in the not thousands, but really in the millions.
One project that we've been working on that's starting to really have some fruition results is we are making stem cells from patients with alternating hemiplegia of childhood. This involves taking usually skin cells from patients, growing them in a dish, and then reprogramming them into what we call induced pluripotent stem cells, or iPS cells you may hear about. And this is a real game changer. It allows us to study human cells from actual patients with these disorders who have the known genetic changes in the ATP1A3 gene. And then from those cells, we can do several things that are amazing. We can turn them into brain cells. We can actually make neurons in a dish. We can study what's wrong with those neurons. We can put drugs on them to help discover new therapies. And the other part of it, which is really great too, is if once I have stem cells, they will grow and you can freeze them and thaw them, and we can ship them and share them. So it will become a resource other scientists around the world will be able to use it to further their own research as well. Moving a couple years further in the future, and certainly within 10 years from now, I think everyone will have very complete genome scans done and really consider a world where we can treat before symptoms even occur. That would be a wonderful change and something I'm looking forward to working on. The other challenge, though, in such a great advance is who's going to pay for this?
The brain controls every aspect of our body, ranging from heart rate and appetite to emotions and memory. It's the brain's ability to perform all these functions that makes us human, and that is why neuroscience is absolutely critical.